everyone. In this video, we're going to talk all about AutoGen in 5 files. We're going to start very simple and then move on to how to set config list, also configure the GPT parameters, how to use the human input mode, the different alternatives, how to use Docker. We're going to learn about that on the 4th file. How to also set up a loop if you wanted to. We're going to learn about how to save the log of the conversations automatically. We're going to take a look at the requirements, how to install WSL to use Docker so that you can run AutoGen in an isolated environment. Look at an example which communicates with the web. And lastly, we're going to take a look at a function calling agent situation, which is really cool. AutoGen is very cool in general. So AutoGen, in a nutshell, is an agent building framework. It's like LangChain, but for building LLM agents very much so easily. It just takes care of a lot of stuff in the background and allows you to get going really quickly. We're going to pip install AutoGen, right? And we're going to do that by pip installing AutoGen. It's updating pretty quickly. So this is the version I'm using currently. From AutoGen, we're importing assistant agent and user proxy agent. So this stands for the user, obviously. This stands for assistant. With AutoGen, you can actually create multiple agents which talk to one another too. In each case, user stands for the user role for each one of them, I believe. Anyway, to get going is very easy with AutoGen, especially if you have your OpenAI API key in your environment variables. This is OpenAI API key. It auto detects it. So you don't even actually have to worry about the config list I figured out, but just take that with a grain of salt. And then the assistant, we send a message to initiate the chat to assistant. What date is today? We run this. The big tech stock is which big tech stock has the largest years of that gain this year? And we do this. We are getting some input. See, as you see, it's writing some Python code. And now it's asking us to provide feedback. Now, normally, if you don't say anything and just press enter, then it will go on and no user input received. It's going to auto-execute the block of code. And it is currently running a Docker container, I believe. Because if you don't specify anything, it automatically runs with Docker. Actually, so that's why you might be getting some error messages right away. But we're going to talk about all that. We tried to run it. There was a mistake in the code, so it got feedback. It's going to correct it. Again, I'm going to let it run the code. Here we go. It actually was able to execute it. And it got that it was Google today, which gained 10%, it says. And after that, it gives us some kind of explanation, and then it gets back to us. In this instance, we can say exit, and we exit the chat. Okay, so this is really how it works. By default, it enables Docker. So we're going to talk about that by the time we get to the 4th file. So let's move on. Let's go to the second one. So this one actually gets a config list. So when you're configuring the config list, it looks at either an environment variable named as this, or it looks at a file that is named as .json. And here, essentially, you're just setting your models that you're going to want to use and your API keys. Here's like a sample one. Okay. So I just set it like this since I'm only using OpenAI, but as a matter of fact, even if you don't set this up, it automatically detects it from your environment variables, which I have done. That's why I was mentioning here that set your environment variable as this particular key right here. It's just the easiest way to deal with OpenAI, I believe, in all cases. Code files for this project will be available at my Patreon as a public post, so you don't have to become a member. But while you're there, please check out all the other Patreon-only exclusive projects. I have over 120 of them. They're all very interesting and dear to my heart. And if you want to know about what projects are there, you can actually visit my website, www.echohive.live, and browse them here, read their descriptions, and find the code download links, and also search for them in real time here as well. So it's very cool, echohive.live. Anyway, so this is how you set it, and then we filter a dictionary from, I believe, which models we want to use. I believe, especially when you're doing evaluation, you can iteratively go over. If I think one of them fails, it'll switch to the other one. Though I'm not 100% sure, I'll be making more videos on this, and as I find out more, I'll let you know as well. Also, all the files here will be available at Patreon for free, okay? So link will be in the description. You don't have to be a member. It's going to be public. So all these examples are available at AutoGen's GitHub, but they're in a notebook, and it's set up as a notebook. So I had to change some stuff to make it run in Visual Studio Code in some instances. So these are just some of the examples that they had there. Anyway, this is the second one. We are, again, so we just imported AutoGen here, and we are instantiating an assistant as the AutoGen.assistant agent. We're just giving it a name. I believe this can be any name. And then you have this LLM config dictionary. Seed apparently is for caching and reproducibility. I believe AutoGen automatically keeps a cache of all the stuff that you're running. For example, here with seed 42, I believe it's saved here in some kind of database. So this way, when similar or exact same response comes in, it can actually pull the response from a previous response, so it doesn't have to make a call to the API. I believe this is the idea behind caching. Pretty sure you can actually cancel this caching. I'm just not sure exactly how yet, but then you set a config list to be the config list, right? Which is this one. And then here you can set all the parameters of the API, such as temperature, max tokens, and stuff like that. Just remember that if you want to set those parameters, this is what you need, LLM config. After that, we are defining a user proxy like this, give it a name. And then here we have this human input mode, never. If we set it to never, then it will never get back it will never get back to you to take input from you. You can set it to always. If you do that, then every time a message is received, so in each iteration, it will actually ask user feedback, just like it was doing in the original example. If we set it to terminate, then the agent will run so many times. And then when it thinks that it's done, it will send a terminate signal. Then, only then, we go back to the user. These are the differences between never, always, and terminate. Even in the case of never, or for example, terminate, we set a max consecutive auto reply to any number you like, here 10, so that as the loop is going on, after 10 times, it will auto terminate. Okay? And here we are just looking at the content of the messages and looking at the terminate at the very end of it. Okay, and then we have this code execution config. You can specify a directory for coding. In this case, the directory's name is going to be coding. And then we have this use Docker to false. I believe if you set it to true, then you will be using Docker. But if you don't set it, I believe it's automatically set to true. And we're going to get to how we can install Docker and run it safely within a container. Then we just initiate the chat. Okay, we're just asking it what day is today. Compare the year-to-date game for Meta and Tesla. Okay, and then we can ask a follow-up question. Let's actually comment these out for now and just run it like this and see what's happening. Here we go. So we got this first. Let me get the current. So it's writing some code. Okay, and because we said user intervention to never, it's executing the code. Okay, and then it got some errors because it didn't find the Yahoo Finance pip install. So it's now going to try to pip install it and then executing the code, this code. Here it installed requests and stuff because it's going to make a request, I believe, right here. Or Yahoo Finance maybe requires requests, so it's just continuing. And now it's going to run the code again. And it's saying today is not defined. So it's getting feedback automatically. It's running like a code interpreter right now. Okay, it ran again. It corrected its mistake and it got the year-to-date gains from both for Meta and Tesla. And then it just terminated, and then it gave us a summary, and then it terminated just like this. And then the script exits. So we can actually send a secondary message as a follow-up message like this, like programmatically. So this is pretty useful. And if I run this again now, it'll first do this and then terminate, and I will send this message after that, which is to plot a chart of the stock price year to date and to save it. And if we actually go to the coding, it actually already had done it without us asking. Here we go. Stock price year to date. Yeah, it had the plotting as well. And the thing to note here is that it has used the specified directory here. But one thing to note is that we are not using Docker, so this is running on our system. So any function that it executes, here we go. I believe it's all done. It can run pretty quickly when it's not running into any issues. And it had written the code that gathered the information requested, and then the code that actually created a chart and saved that chart. Now we can, alternatively, I'm just going to go ahead and comment these out, and we can actually start a loop. As you see, pay attention that we set a first message to true, because if the first message true, then we're going to initiate the chat. Otherwise, we're just going to be sending messages. So if it's the first message, we initiate chat with some user input. Otherwise, we send a message. If we run this, now we're just going to be able to just tell it to do some stuff, like, for example, tell me, it actually wrote some Python code for a joke, and then it got back to us, and we can actually continue talking to it. So you can set this as a loop as well. I'll comment the loop code out, but you can comment it in when you're experimenting. I'll just leave this one. Now let's take a look at the third file. Again, we are getting our config list from OpenAI config list. And as you see, it's all it is this thing right here. And it's still working, although I don't have my API key here because I have my API key set up as an environment variable. I just want to make that clear. But you can enter it into OpenAI config list.json, just like this, I believe. And here's a sample file as well. This is like a list. I wasn't entirely sure how to put this. I believe the list should work if you have more than one. Again, we are defining an assistant with LLM config. We're setting a seed, right? This is for caching purposes, as we talked about. We're defining its config list. Then we're creating the user proxy agent. This time we're using human input mode as always. So each iteration is going to ask us. We are still looking for terminate. And we're setting the work directory as coding and use Docker false. We could have changed this directory to anything. For example, let's just change it to tester, as a matter of fact. And then here it's going to ask the purpose of the following line is to log the conversation history. So you can actually start logging your conversation like this. And then at the end, you can actually save it. Okay, like this, logged history to conversations.json. You do need to import JSON. You can import it at the top or right here. We're just dumping to a JSON file, the logged history. So this is how you actually can keep track of the conversations in a file, just like this. And we have given some math problem here, and we're just going to run it. We are given we're initiating the chat with that message, and we are sending that message to the assistant, which we have defined right here. Okay. I'm just going to go ahead and delete the conversation.json so we can see what happens in the end. I'm just going to let it running. Here it's doing the regular thing as apologizing. Let's see what happens. Okay, the first time around, GPT got into the mood of saying, I'm just an AI, I can't do that. But the second time around, it got the question and it's now arranging it. And it's going to try to use this library, Senpai, to actually evaluate this expression. And so it wrote some code and it got back to us immediately because we set human input mode always. Remember, if we can provide feedback to it, but if we wanted to continue uninterrupted or execute the code, then I'm just going to input nothing. And I believe it tried to execute and got some error. It's now trying to run further. You have to enter user input at each time, which is nothing, literally just pressing enter. It mentions here, press enter to skip and use auto reply. It will auto execute code if it's auto reply. Oh, and it was able to run the code and the output of the code is 0. And it gives us that evaluation of that mathematical statement was 0. And it says to us to verify and check. And then after that, it received terminate, right? And that's why this conversation was terminated. And because we kept track of the logging, like this chat completion.start logging, and because we saved it to a JSON file, we can see what happened in our conversation along with our costs. I'm not sure what these costs are exactly based on, but it's there. You can take a look. Now let's take a look at our fourth file. In this one, we're actually going to be using Docker. Like I said, it's actually pretty easy. I'm surprised. You just said use Docker to true in code execution config, where we set the code directory. And I do want to mention that the test directory was also created when we specified this directory for the file number 3. Anyway, we said use Docker to true, and I believe Docker uses set to true by default. If you do a quick search and install WSL2 in Windows, because you need the Windows Linux subsystem, the first link, which I'll put this link in the description, says simply to run this command in PowerShell WSL-install. Okay, you can run this by starting a PowerShell, like from your terminal, and then running that command. I already have it installed. I'm not going to run it. I also put that here in the requirements. After you install this, you're probably going to need to restart your computer. Then you need to go to Docker and then find the Docker desktop and download it, in this case for Windows, for me, okay? And once you download it, you have to run it and install that, and you're going to have to restart your system again. After which time, you just start your Docker, meaning the Docker app, and AutoGen will automatically create and delete Docker containers on the fly, so you don't have to worry about that after that. If you take a look at this file, we are again sitting in the config list. And then see, in this case, the models are specified as 32K, even though I don't have access to it. I believe it just uses the first one. Yeah, -4. LLM config here, like we said, you can set the request timeout. This is an OpenAI parameter, just in case if the API is non-responsive for 600 milliseconds, I believe, it'll break away. See, we're setting the seed for caching purposes. Config list is config list. Temperature, you can set other parameters here, such as mix token. Then we are defining the assistant with this LLM config. We are setting the human input mode to terminate. So once the agent gives a terminate message, then the AutoGen will get back to us. We are setting how many times auto reply can continue to 10. So it will auto terminate and get back to us after 10 iterations. This is how we're detecting if terminate is at the end of the content of the assistant messages that are generated. We are setting the code execution config to web this time, because we are going to be using some web utilization here. We set the use Docker to true, and we are setting a system message. Pay attention that apparently you can set a system message for the user proxy. Here it says reply terminate if the task has been solved at full satisfaction. Otherwise, reply continue, or the reason why the task is not solved yet. Then we just initiate the chat by asking who should read this paper, and giving the paper's URL. Now, if we run this, look what's going to happen. I'll have the Docker here on the side. Look, it has started automatically a Docker container and immediately terminated it, I believe, after code execution. So it just keeps doing that. So once you install Windows subsystem, if you're on Windows, you see it started code execution again, and it started another Docker container. Essentially, when it's running its code execution, and if it uses Docker, then you can, for a great extent, you can think that your overall system is safe, because Docker container is isolated from the rest of your system. Like I said, if you simply install WSL-install in PowerShell, you will have installed Windows subsystem along with Ubuntu. Then you install Docker desktop, and then you just start the Docker desktop, and that's all you need to do. And as we see in the background, AutoGen is doing all kinds of stuff. It's actually trying to run this code. See, as you see, it's importing beautiful soup. It's actually trying to get the abstract of this URL. Let's see if it's going to succeed. It's still working on it. Oh, yeah, but eventually was able to get the abstract of this article, all the while executing the code in Docker containers. And now it just gave us our answer based on the abstract, who this paper is for, right? Researchers and developers, professionals in coding, so on and so forth. This is really lovely. I will be experimenting more with AutoGen as well, like I said, with my own ideas too, and I will utilize some of the other examples from their repository as well. But all these files will be available in my Patreon, like I said, for free as a public post, so link will be in the description. Now finally, let's take a look at a function calling agent configuration. We are again setting the config list. We are this time using config list from model. Before we are using config list from JSON, right? Looking for the OAI config list like this. But in this case, we are defining it from list from model, just like this, GPT-4 and 3.5 Turbo. And nowhere here we are specifying the API key, and this will still run because I have my OpenAI API key set in my environment, Windows environment variables, okay? It's auto-detecting it from there. So this code was particularly set up for running in a notebook. That's why I modified it to run in Visual Studio Code as a regular script. That's why we're using subprocess. Here again, we're using LLM config like we've used here because we are defining because we need to define all the parameters of the API, such as temperature, mix tokens, or request timeout. And since functions definition is part of the parameters, API parameters, we're defining it here, just like we would normally define function definitions, right? Yeah, we are just sticking true to the regular convention. Run code in Python, return the execution results. This is for running shell scripts. All right. And then we are defining the config list as config list, request timeout at 120 milliseconds. And then we're defining the assistant as a chatbot, as name. So this can be anything you like. We set a system message for coding tasks. Only use the functions you have been provided with. Reply terminate when the task is done. LLM config is LLM config because it needs this function definitions. And the user proxy is user proxy. It looks for terminate, right? It never wants to get user input. So this is we won't be able to input any feedback with this setup. We are still limiting the loop to 10 iterations. Code execution config, we are going to use true, and we're going to use the working directory of coding. And then we have these functions. We had the function definitions. So now these are the functions for that. To execute Python code, to execute shell. As you see, these were the names, Python and shell. And here, after that, after defining, we are registering the functions, user proxy.register functions. We are mapping the functions. Python definition maps to exec Python function. Sh maps to exec underscore sh function. So this is how you register the functions. And we are using the user proxy to do that. Because, yes, why do we do this? If you think about it, so the assistant gets the descriptions and will return the parameters for those functions, and then the user will be the one that is responsible for executing it, right? This is how we would do it if we were doing it the pure OpenAI way. We would receive the functions, and when it is user's turn to respond, then we would execute the functions and get some return from the functions, and then we would input that back in when it was user's turn. I guess that's why they're like simplifying it like that. And then we just start a conversation simply. So we initialize it from the user proxy, and then we input whoever this message is going to, and it's going to the chatbot, which is the assistant agent, which we have initialized up there. Okay, just like that. And now we have this message, draw two agents chatting with each other with an example dialogue. Save the plot to a file too, I said. So this is a kind of very obscure, but essentially it should still work. Let's see what happens. Okay, let's see. So it was having some issues. So I'm just going to say use matplotlib to draw two agents chatting. Let's see what it does. This was one of the examples, actually. So it's an interesting, well, it's a bit of a weird example, but an interesting one nevertheless. Okay, this is the message we just sent. In theory, you should write some matplotlib Python code to simulate two agents talking to one another, I believe is the main idea, if I'm not mistaken. Here we go. Yeah, so it did that. So it did it somewhat. Anyway, it ran the code, and that's it. And I don't know why, if in this case it's not using the coding directory. In my previous tries, it didn't use it either. Although we are setting the working directory to coding, it did not save the PNG to that folder, but it saved it to the main directory. But keep everything about AutoGen with a grain of salt. Like I said, this is a pretty new library, and I'm sure it's going to get improved quite a lot. It's very exciting, very promising. And I hope you found this useful. So I hope this will get you started and get going quickly. If you enjoyed the content, please feel free to subscribe. Let me know what you think in the comments, or join our Discord server and chat with us there about all this stuff. Link will be in the description. Thank you for watching. Code files for this project will be available at my Patreon as a public post, so you don't have to become a member. But while you're there, please check out all the other Patreon-only exclusive projects. I have over 120 of them. They're all very interesting and dear to my heart. And if you want to know about what projects are there, you can actually visit my website, www.echohive.live, and browse them here, read their descriptions, and find the code download links, and also search for them in real time here as well. So it's very cool, echohive.live.